Hello everyone. Good afternoon all of you. I hope you are fine. Today we are doing with our next class of their kinetic theory of the gases. We have done in last class we discussed there about the kinetic theory of the gases. There degree of freedom topic we discussed beta how you can find their degree of the freedom for the different gases monoatomic, diatomic and the triatomic, and triatomic can be non-linear and can be linear. So how we can find their degree of freedom we discussed already. Today we will discuss their specific heat of these gases, how we can find. So here for a monoatomic that it will be a 3/2 kBt degree of the freedom 3, then energy of this one we can write there 3/2 kBt. For diatomic then we can write their degree of freedom will be 5. How we can find beta by using this one formula? We discuss this one formula that is equal to your F equal to your 3n minus K. This one formula we have done of the degree of freedom. By using this one formula we can find their degree of the freedom for the different gases. There can be mono, di and tri. For the monoatomic we had done 3. For diatomic then it will be 5, and for triatomic then it can be, for triatomic that can be non-linear and linear. For non-linear then it will be 6 and linear it will be 7 only. So here we can discuss beta this one. So our next one we will find their specific heat at constant volume. We will find there. Okay, so this one at constant volume, then we can write there CV, and CV we know about this one relation, this one rate of change, this one here internal energy with respect to change in the temperature. Here T is beta temperature, not your time. So U is internal energy, and with respect to change in the temperature, by this one we can write their specific heat. Specific heat, that how much we can increase their temperature of the 1 mole of the gases at the constant volume, then we will call it specific heat du by dt. Okay, so first we will find their CV. How we can find their CV? So for this one, here now total gas energy, kinetic energy per molecule, it will be equal to beta 3/2, not 3/2, it will be 1/2 kBt. Okay, this one we have done already. So by using this one, as we know, then kb equal to your into your n Avogadro number, then it will give us R. Okay, because we have done beta this one relation, because here Boltzmann constant हमने discuss किया था. Boltzmann ratio is a ratio of the gas constant to the Avogadro number. ये हमने relation discuss किया था. By using this one relation we can write their Kb into your Avogadro number, then we can write their equal to R, that is your gas constant. So as we are multiplying this one with your Na, so here we can write their 1 kBt your for the Avogadro number, then we can write there 1/2 RT. So for the triatomic, first one for monoatomic gases हमने फाइंड किया था डिग्री ऑफ फ्रीडम. सो डिग्री ऑफ फ्रीडम F इक्वल टू फॉर मोनोएटोमिक आवर केम ना 3, हमने फाइंड किया था बेटा बाय यूजिंग दिस वन. कहां से फाइंड किया था? F इक्वल टू 3n माइनस K. अगेन आई एम टेलिंग यू. तो F क्या था? हमारा डिग्री ऑफ फ्रीडम था. N क्या था? नंबर ऑफ दी गैस मॉलिक्यूल्स, एंड K इज आवर रिस्ट्रिक्शन. कितनी उसके ऊपर क्या चल रही है? रिस्ट्रिक्शन चल रही है. सो हाउ वी कैन फाइंड बाय यूजिंग लाइक दिस वन. Then number of molecules in your monoatomic, then it will be 1, restriction will be equal to 0, then it will give us 3 only. तो इसको फॉर्मूला यूज करते हुए F क्या आ जाएगा आपके पास? 3 आ जाता है डिग्री ऑफ फ्रीडम. सो here we can write their total total internal energy, total internal energy per degree of freedom, degree of freedom. So here we can write there beta total energy. How we can write there? U equal to, you can write their internal energy 1/2 RT and into degree of freedom. For monoatomic, then F equal to your 3 only, because you are monoatomic, then F equal to 3 degree of freedom came. So here internal energy we can write there 3/2 RT. It will be a 3/2 RT internal energy. Okay, after this internal energy, then this one will be here for the monoatomic. Then after this one we will find their monoatomic. For the diatomic also we will find there. Then here specific heat, how you can find there? As we know that Cv equal to change in internal energy with respect to time. So using this one, then we can write there d by dt 3/2 RT. Differentiation with respect to temperature, then this one factor will be remain constant, take outside from here, then here left here 3/2 R, then here dt by dt. So here we can write there 3/2 R. तो ये क्या आ गया हमारे पास? Cv आ गया स्पेसिफिक हीट फॉर द कांस्टेंट वॉल्यूम 3/2 R. और किसके लिए ये? फॉर मोनोएटॉमिक गैस के लिए, फॉर मोनोएटॉमिक गैसेस के लिए, monoatomic gases के लिए. Okay, using this one beta we can find their gamma also. How we can find their gamma? This one your specific heat at the constant volume for the monoatomic gas. अगर आप gamma find करना, gamma is the ratio, is your ratio of the specific heat, ratio of the specific heat Cp by Cv. Okay, gamma is equal to Cv by Cp. This one how we can write there? Then here Cp how we can find there? As we know Cp होता है बेटा dq by dt, differentiation of heat with respect to temperature, then it will give a specific heat at the constant pressure, but in our there having not having heat. That's why we can't use this one relation. Here we will find this one Cp by using your Mayer's formula, and Mayer's formula equal to Cp minus Cv equal to your R. Okay, using this one relation, then we can write there Cp is equal to Cv plus your R. So Cp we have find out that is equal to 3/2 R plus your R. Solve it, then Cp will be come out here 5/2 R. R यहाँ से कॉमन निकाल लेंगे, कॉमन निकल के क्या बचेगा 3/2 + 1, उसको सोल्व करेंगे तो क्या आ जाएगा 5/2 R. तो ये हमारे पास क्या आ गया? Cp आ गया. तो हमारे पास Cv आ गई ये एंड Cp है. देन वी हैव टू फाइंड आउट गामा. सो यार गामा फॉर मोनोएटॉमिक गैसेस, किसके लिए? मोनोएटॉमिक गैसेस के लिए, मोनोएटॉमिक गैसेस के लिए. सो हाउ वी कैन राइट देयर गामा इक्वल टू यार Cp माइनस Cv, गामा इक्वल टू Cp बाई Cv. तो Cp हमारे पास क्या है बेटा? दोनों की वैल्यू हम पुट करेंगे यहाँ से उठा के. Cp इज इक्वल टू 5/2 R एंड Cv इक्वल टू 3/2 R. Cp इक्वल टू यार 5/2 R and your Cv equal to your 3/2 R. We can check again. This one only came 3/2 R for the monoatomic, and solve this one by using Mayer's formula, then it will give us 5/2 R. So after this one putting here, then gamma will be equal to your 5/2 R divided by your 3/2 R. Then R to R cancel out, 2 to cancel out, then it will give us 5/3. This one your gamma specific heat ratio of this one here monoatomic gas, then it will give us 5/3. I hope you understood beta how you can solve this one gamma for the monoatomic gas, जिसके अंदर n क्या होता है बेटा? n number of the gases particles will be equal to 1. Okay, तो इसके लिए हमारे पास गामा ये आ जाएगा. Further in point, if you want to find out, then you can find it 5, that it will be equal to your 1.4 something like this one will be there. Okay, now next will be there for the monoatomic specific heat ratio gamma for diatomic gas. What? Diatomic gas. So again, how we can find for the diatomic gas specific heat? Now here again we will find beta internal energy first. Internal energy, how we can write there? CV equal to your dV by dt. इसके लिए पहले हमें क्या निकालना पड़ेगा? CV निकालना पड़ेगा. CV क्या होगा? Differentiation of the internal energy with respect to the temperature. So internal energy we will find it. Internal energy, how we can find there? Kinetic energy per molecule equal to your 1/2 kBT. Okay, so degree of freedom for the diatomic की बात कर रहे हैं. diatomic या degree of freedom for diatomic हमने सोल्व कर चुके बेटा ये चीज. तो क्या आता है? diatomic के लिए डिग्री ऑफ फ्रीडम कितनी होती है? 5 होती है. So here kinetic internal energy per degree of freedom, then here we can write there 5/2 kBT. Here this one here 5, multiply this one 5 with your per molecule, then here we will get there 5/2 kBT. Okay, 5/2 kBT, this one our internal energy. So for, as we know relation between them, your R and kBT, as we know this one your R equal to N Avogadro number